Alright, so 2.4, reasoning with properties from algebra. It's on page 96. You should hopefully be doing this Tuesday, September 15th, or maybe Wednesday, September 16th. But always earlier in the week is better, because then you have it done. You can ask questions and figure things out. So warm up here, there's two similar expressions here. We want to make sure that you know the difference between these two things. Hopefully you can pause the video maybe and try this one and see what you get, and then come back. Hopefully we don't have to we probably will keep saying pause all year to remind you, all semester hopefully. So here, if you paused and tried this yourself already, this is the parentheses aren't really doing anything here. We have 2x minus 7, and then we're going to subtract 5 more. So that's just going to be 2x minus 12. So what we're trying to emphasize is do not mistake these two things for each other. This one is multiplication. So here we're actually multiplying both of these by negative 5. So that's the distributive property from the other side. Normally we don't write it back there, but we want to make sure you understand this is not the distributive property because it lacks the parentheses. So that's just going to be negative 10x minus 35. And like I said, the way we normally would have that is we would normally have that as negative 5 in front, like this. But all right, so laws of detachment and the law of syllogism. So in the syllogism, we are looking for a beginning and an ending that are the same. So syllogism, we are looking for a beginning and ending are the same. Now this is in Spanish. I had Spanish a long time ago. I think I remember what those things say. But it doesn't matter if you know Spanish or not. I think one of our examples was in French. I think one of our examples we actually it's not even real words. All you need to do is remember that syllogism means a beginning and an ending that are the same. So I see cansado and cansado here, so those two are the same. So I want to take the parts that are the same and I want to eliminate them. So we're saying this, then this, this, then this. So A to B, B to C, we can go directly from A to C. So we can basically cancel those out and we just write down what's left. So if you are sick, I think is what that says. If you're sick, then you should rest. Then rest. Or I think it's rest or sleep. Okay. And cansado means tired. So if you're sick, then you're tired. If you're tired, you should rest. So, all right. Now, we could look over here. Is there a beginning? It's got to be a beginning and an ending that are equal. We need the beginning equals the end. So here's a beginning that equals the end. And then the answer is the rest, what's left. Over here, there's an end that matches an end, but there's no beginning that matches an end. So this is just some symbols, and then nothing we can do with that in this syllogism situation. Now, detachment, remember that's when we have something that's detached. So something that's detached would be this or this. Those are detached. But the detached thing has to be at the beginning. So here, this is not at the beginning, so we're not going to use that. Not the beginning. So we move over here. This actually is at the beginning of something. So if we have this, then we have delta. If this, then this, we have this. So the answer is the ending. So if we have a beginning, then the answer is the ending. Detached, if something's detached, it's broken off. So normally we have an if-then statement, but here this part is detached. We just have the beginning. Here, this statement is detached. There's no if or then. It's just a detached statement by itself. So we've asked that a few times. That's a common test question, usually in person. So that's the warm-up. So now that we've finished the warm-up, and I forgot to say pause during this one, I think, but hopefully you tried that out yourself. That's one of the most important things you can do in our class is practice trying to answer the questions in the notes. Okay, algebraic properties of equality. So it would be nice if you try to pause this and then fill in these things on the side and play. I would play, don't fill them all out, just put this one, then pause, and then unpause it and see if you got it right. Then pause, then put this one, and then unpause, and do one at a time. In case you made a mistake, you'll see what that is. So the addition property says if A equals B and we add something to A, we can add the same thing to B. And here the subtraction property of equality says that if we have two things are equal, we can subtract the same thing from both sides. You've been using these properties for a couple of years at least. If multiplication, if A equals B, then we can multiply both by C. If A equals B and C does not equal 0, then we can divide both sides by C. They have to say that because we don't want to divide by 0. Dividing by 0 is bad. Usually on the test, this is a matching question. Although actually, there's also kind of a fill in the statement. So, but there is one type of question on this that is normally matching. All right, reflexive property. You need to memorize these. So reflexive property says for any number A equals A. That seems kind of silly, but a number is equal to itself. We actually use that for something else later. Symmetric property just means you can flip it over and it's the same. So if A equals B, then B equals A. Okay, transitive property, if A equals B and B equals C, then A equals C. That if they both equal B, then they must equal each other, which, by the way, is similar to our warm-up up there. It's kind of like the law of syllogism, the transitive property. They're very similar. And finally, substitution. If A equals B, then we can put A anywhere that we see B in an expression or an equation. We can substitute A to replace B. Okay? So, here we're going to solve this equation and we're going to write a reason for each step. Now, you guys should have been writing these out for a while, so it shouldn't be that big deal. The main thing is you want to get the reason. So there's two things you want to keep in mind now. Number one, this is important because, well, normally we try to grade things this way. So, variables first. Deal with the variables first. And step number two, keep the variable positive, or get the variable to be positive. So as you're doing your steps, we want to try to make sure everybody's doing their steps the same way so we can keep track and grade and everything like that. So we just said, do the variables first and keep them positive. So we're going to deal with the x's, and I'm going to subtract 3x from both sides because I want to keep the variable positive. If I subtract 8x from both sides, the variable will become negative. So we're subtracting 3x from both sides, so that's the subtraction property of equality. Now, if you're going to try to abbreviate that, don't use SUB because subtraction and substitution both start off with sub. So I would use, if you're going to abbreviate, really you should use 4 letters if you're going to try to abbreviate that. But we can just use the minus sign there. Works fine. So that gives us 12 equals 5x minus 18. So the variable is positive, and we did the variable first. Now we have to deal with this number, so we're going to add 18 to both sides. So we just use the addition property of equality. and that's going to be 30, and there you go. And so our final step here is going to be, you could say divide by 5, or you could say multiply by 1/5. Either way, I think most of you would prefer to just say divide by 5, so we'll do that. So that's the division property of equality. We also could have said times 1/5, which you could say, you could call that multiplication, or you could say the multiplicative inverse. Multiplicative inverse. But you don't have to do that. Alright, so that is 6 equals x. And then we could say one more thing. A lot of teachers like the variable on the left, so we could flop that over. And that would be the symmetric property of equality. Alright? So that's usually a test question where you have to write those steps out and you get a point for each. So a point on this side and a point on this side. So usually that would be about 8 points there. So yellow highlighting are test questions. So when you see something highlighted in yellow, that's something you want to keep in mind for a test. Other highlighting is just to draw our attention to certain things. Okay? So B is between blah, 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 blah. So when I look at all that stuff, I'm like, maybe you can visualize that in your head really easily. I would rather have a picture. So I'm going to draw a picture of that. And I know that there are 4 points on there. And I don't need to have this exact or whatever, but B is between A and C. So A, B, C. And C is between B and D. So I'm just going to go, I don't know, over here. So B is between A and C. And C is between B and D. So that worked out fine. Especially if you're using a pencil, you can erase if you need to. So I've just sketched out a situation. You can see here they already gave us a drawing, so that's nice. So let's see. AC is equal to BD. So remember, that's the length because there's no symbol above it. So it's saying the length from A to C is equal to the length from B to D. This number is equal to this number. So AC is right there, and BD is right there. Now they may not look equal in your drawing because you just did a sketch and you didn't know the sizes of stuff necessarily. So they might not look like it matches. Now they want us to prove that AB is equal to CD. So they want us to prove this little piece here is congruent to that little piece there. That's what we're trying to show. Now, a couple things that should be free. So, first of all, they told us that AC equals BD. So we can write that down. AC equals BD, and that's given. Okay? So those should always be free. This should always be given. So that should be a free point for everybody. Okay? And that varies, but it's still given. The thing you're trying to prove is going to be your last statement. So your last statement here is going to be AB equals CD. So those three things should always be right there. Free points. Okay, now there's different ways to approach some of these. So usually on a test we try to fill in some for you so that it gives a structure to a direction to where you want to go with that. So Let's see here. I'm trying to get these pieces. I've got this whole piece. This is a part of that whole thing. This is a part of this whole thing. So usually when you see a segment divided up into parts, you want to add some stuff together. So how about if we say AB plus BC equals AC, and over here we could say BC plus CD equals BD. Now think about what we just did. We took the lengths of some segments and added them together to get a bigger segment. So it's pretty much telling you exactly what it is. It's a segment addition postulate. So we have the segment addition postulate because we're adding the lengths of two smaller segments to get the length of the bigger segment. Okay? Now, if you look up here, AC and AC are the same thing right there. So, what we can do is we can replace this with this. My phone just thought I was talking to it, so it asked me what was going on. Because I said these two letters, and the way I said them, it sounded like my phone's help system. Alright, anyway, back to this. So we're going to replace AC with this. So we're going to say up here, we're going to replace that with AB plus BC. And over here, we're going to replace BD with BC plus CD. Now, what we did was we took this and we substituted it in for AC. And here we substituted this in for BD. So I obviously was trying to give you a pretty big hint there. That's going to be the substitution, subs property of equality. Okay, now, so now we have this plus this equals this plus this. We have this pink part equals this pink part. We're just trying to get those pieces. If you notice, the two pink pieces overlap from B to C. So what we can do is we can say that BC equals BC. Anytime you say something equals itself, that's the reflexive property of equality. And now, if BC is equal to itself, if we subtract BC from both sides, so that would be the subtraction property of equality. If we subtract BC up there, we just get left with those pieces. Okay, so excuse me. So we know we're trying to find the measure angle 4. So I can put that down here. Measure angle 4 equals something. That's what we're trying to find, so that's going to be our last step. They already gave us a given. So one way to do these is, does this tell us something? And it probably does because I just highlighted the whole thing. So what I hope you notice if you look at those, you can pause it and think about it, is that this and this are the same, which means that I can replace the measure of angle 1 plus the measure of angle 2. That can be replaced with 93 degrees because these are equal. So I can take this out and I can put this in its place. I can substitute. So it's going to be 93 degrees. Now this is gone because I switched it for this, plus the measure of angle 3 equals 180 degrees. And we just said that's the substitution property of equality. Okay? And that came from there. Now, if we look at this, we should be able to solve that. We can just subtract 93 from both sides. So subtract 93, subtract 93. So the measure of angle 3, if you subtract 90, you would get 90, but we have to subtract 3 more than that, so that would be 87. Okay, so I just told you, you can see what we're doing right there. So that's the subtraction property of equality. Now we have another given piece of information here, and we have another pair of things telling us about something else. So we can think about that, pause the video, think about what we're doing here. Okay, so these are equal. That's the same as that, so I replaced it with this. So again, that's the substitution property of equality, same as that. I just wrote it out instead. All right, so, well, now we're almost done here. We just need to subtract 87 from both sides. So that's going to be 93 degrees, and that was the subtraction property of equality again. All right. So, two things you want to do when you factor. Always check for a GCF, and that's number one. And number two, ask yourself if you can factor again. All right. So these are all even. That means we can factor out at 2. Doesn't matter that it's P. Well, it shouldn't. All right. So now we factored out the GCF. So what I tell my students is they could just write that number down there right now, 2. It's got to be 2. Now you're going to factor this. Now, because A equals 1 now, because we factored out the 2, this is pretty simple. It's got to be P and P. This is positive. That's negative. That means this both has to be negative in order for a negative times the negative to be a positive. And now I need factors of 27 that add up to 12. 2 doesn't matter here. So factors of 27 are 1 and 27, 3 and 9. That's about it. So 3 and 9. Now there's no equal sign, so we're not solving. We just stop there. Okay. All right, so we look at this next one and we say, is there a GCF, greatest common factor? No, there's not, because 23 is prime. So the next step, what we do here, you may have learned different ways before, but this is how we're going to do it. It's pretty straightforward and it's faster than a way we used to use. So whatever number is being multiplied out in front, if there's no GCF, we just write that as a fraction. So 1/12. 12, we're going to do 1/12. Then we write 12b and 12b. Same thing both times. Now if you think about that, if we multiplied this out, 12 times 12 divided by 12, then we would just have 1/12. So that's fine. We've just rearranged that somewhat. Now, the next thing you do is you take A times C. You take the first thing times the last thing. So that's going to be 12 times -9. That's 90 and 18 is 108, and it's negative. So negative 108. Now, another thing you could look at real quickly here is this. Because this is negative, that means this has opposite signs. So one of them has to be positive and one of them has to be negative. So when we multiply them together, we end up with a negative. So we know that as well. Now back to the factors. We need to find two factors of 108 that add up to 23. So if you're not sure, you could just start listing them all. 1 times 108. Now because it's negative, we're going to be subtracting these two numbers. So if we subtract those, we get 107. That's not even close. So I know I probably should skip down a couple numbers, but I'm just going to go in order. So 2, that's going to be 54. That's not 23. Okay, so now, what about 3? Does 3 go in there? These digits add up to 9. So if the digits add up to something that's divisible by 3, then it is divisible by 3. So 9 is divisible by 3, so this is divisible by 3. So 3 goes into there 36 times. So we're getting a little bit closer, but that still does not work. So now, because we had 2 times 54, that means I know I can factor out another 2, which would be 4. So if I divide that by 2, I get 27. And there we go, because 27 minus 4 is 23. But it's a negative 23, so I want the 27 to be negative, and then I want the 4 to be positive. So now we're going to divide. So we can divide both of these by 4. Divide those by 4, that's going to be 3b plus 1. And this, we're going to divide both of those by 3. So 12b divided by 3 is 4b, and negative 27 divided by 3 is negative 9. And that's the answer. So hopefully you can pause it and try the next one yourself. Factoring is a very important skill in Algebra 2, and we use it a bit in geometry also. So hopefully you paused and you came back and you already wrote 1 over 12, and probably 12x and 12x also, hopefully. Okay, now this is positive. That means the signs have to be the same, and they're going to be the same as whatever this is. So that's positive, so these are both going to be positive. And then we're going to take a times c again. So 12 times 10 is 120. Now I need the factors of 120 that add up to 29. Now we already have, just kidding, not the same thing. Alright, so 1 and 120, do they add up to 29? No. 2 and 60, 3 and 40, 4 and 30. It's closer. That's 26 and 34. We're getting closer. It's probably, hopefully we all know we can divide that by 5 because it ends in a 0. So 120 divided by 5 is 224. 24 plus 5 is 29. So we can factor out a 12 out of here, and that's going to be x plus 2. And last one for today. First of all, and on all these questions we should have asked, can we factor them again? But none of them did, so we're okay. Here, hopefully, you see that it's because those all end in 0s and 5s, that means we can divide that by 5. So hopefully you pause it and you do that yourself. Excuse me. All right. Now, we don't really want to mess with the 5 all that much. Maybe we can just put that down on the answer already. It's going to be a 5. We can just focus on this part right here. So we just said a couple times what to do with this number. 1 over 6. And then we said write this, except for the power, write that same thing down. So 6y, 6y. Excuse me. All right. So this is negative. That means these have to be opposite signs. And we can take a times c, we're going to get negative 120. So I can look at these pairs of factors over here, but the signs are opposite, so I need to subtract them. So can I subtract any of these pairs to get 35? That's 24. $29. Oh, these are opposite those for subtracting. So don't get distracted by this or the 5. We want to focus on this. So that's where the 120 came from. So the factors of 120, and they're opposite, so that subtract to give 7. So if you go down here and subtract those, none of those give 7. So we can carry on from here. So 6 and 20. 20 minus 6 is 14. That's still too big. So 7 does not go into 120, but if we do 8, and how many times 8 go into 120? 15. And we need to get 7. So if we do positive 15, negative 7, we can factor out a 3 out of here. And that's an 8, not a 7. I was looking at that 7. So the 3 factored out of there, and a 2 factored out of here. So if we factor a 2 out of there, that would leave us with 3y minus 4. Now, the 1/6, when we factor this out, cancels that. On all those, that fraction up front, when we factor out the 2 numbers from here, they cancel. All right, so that wraps that up. I can't see that behind there. So if you need help on factoring, maybe we can do that on Alex or something else.